We're going to launch our discussion on data center sustainability. Would you please welcome staff engineer at Lawrence Berkeley National Laboratory, Dale Sartor.
Thank you. I'm going to give a little context here. In 2007, Congress asked EPA and DOE to study the data center market, study the energy uses and trends, and then identify possible scenarios for energy and efficiency. And as you can see, that was the black line up till 2005 or so. The study was done in 2007. And then the dotted lines were the projections based on different efficiency scenarios. Just this year, we completed a relook at that study. So, 9 years later, it was restudied, and you can see there's been a dramatic change in data center energy consumption. Instead of doubling every 5 years, we've leveled off, but there's still some growth. We're at about 1.8% of our U.S. electricity use is in data centers, so that's doesn't sound like a lot, but that's a lot. It's more energy than most states use. It's growing a little bit slower, so we've made some good progress, but there's still a lot of opportunities, and that's the lower graph on the right-hand side is the efficiency opportunities that illustrate that under both a let's see, it doesn't have it down there, but with best practices and a greater shift to hyperscale data centers, we could see a 45% energy efficiency improvement. Okay, I must be using the wrong button. Oh, I see, okay. Okay. What button do I use?
Well,
Oh.
Whatever you hit. I didn't do that.
I'll have the same problem next time, I bet. Okay, so what are the drivers for federal agencies? We have two major drivers, the executive order that's been the topic of this conference, and then just recently announced in the last few weeks is the Data Center Optimization Initiative. They complement one another. The requirements are that we install advanced energy metering in all data centers by FY18. This is a pretty significant requirement because most data centers in the federal sector aren't metered. And by advanced metering, it means that we have to actively track power usage effectiveness. And that's a term used in our industry. It's the total data center facility power divided by the IT energy. So in a typical data center, there'll be 1 watt. For every watt that goes to the IT equipment, there's another watt that goes to the infrastructure, like the cooling and the electrical conditioning. So in that situation of 2 to 1, that's a PUE of 2. So obviously, the best you could do would be no infrastructure, and that would be a PUE of 1. But the average is about 2 in the federal sector. The goals that have been set for us have been for new construction to be between 1.2 and 1.4. Really what the bottom line is, that's 1.4. And then in retrofit or existing data centers, we're supposed to reduce our energy use to below 1.5. So in the typical federal data center, that means a reduction in our infrastructure use of half. So that's a pretty aggressive goal, but it's doable. What are our options if we have a mission-critical data center, but we say we just can't afford or it's too small to do that? The response from OMB is to close that data center, either consolidate it to another data center that can meet the requirements or to move to the cloud, which we have a cloud-first policy. No, that's going backwards, okay. Hey, I guess if I push the buttons enough, it finally goes. So this is a laundry list of the opportunities. There's no real silver bullet for data centers, but we have a lot of silver BBs. It involves, the first step is measuring and benchmarking. You really can't manage what you don't measure. There's opportunities on the IT side. We'll hear from Orlando on that. Optimizing the environmental conditions. If you're in a data center and you have to wear a jacket, that's an indicator that there's a lot of opportunities because IT equipment can run at much warmer temperatures than we feel comfortable at. We need to manage our airflow. We can evaluate cooling options from basic better controls to going all the way to liquid to the chip. We can improve the electrical efficiency, and then we can use IT equipment and software. We can use IT to save energy in IT. For help in applying or understanding these opportunities, the Department of Energy has stood up the Data Center of Expertise, and the website is datacenters.lbl.gov. And at that website, you can get a range of available resources. We have various tools, guides, case studies, report templates, and also information on the Data Center Energy Professional, which is a professional certification program that's called out in the executive order. So with that, I thank you very much.
Thank you very much, Erlen. And right now, we'd like to introduce the Vice President for Consulting and Intelligence at Hewlett Packard Enterprise, Orlando Figueredo.
Well, good afternoon. And I want to piggyback on Dale's presentation by really focusing around the IT of data center sustainability. So really, first, the bad news. Even though we've got these executive orders and we've been looking at data center sustainability for quite a long time, the average data center today still has between 20 and 30% of its servers sitting idle, what we call ghost servers. In addition to that, the remaining servers usually run somewhere below 20% utilization. So sustainability and efficiency is still an issue that we need to work on today. At Hewlett Packard Enterprise, we drive IT efficiencies around three main vectors. The first one being around equipment efficiency, and that's really using IT at the highest utilization levels. Most of the time, that's with high virtualization rates. The second one is around energy efficiency. That's really IT with the highest performance per watt. And a lot of times that means using optimal and energy-efficient power supplies. And then the last one is really around resource efficiencies, which is really using the least amount of equipment that you need in your data center and making sure that your IT equipment uses the least amount of material, so the smallest footprint that you need to do your business. So let's see if I can run the slides here. All righty. The building blocks for efficient computing for Hewlett Packard Enterprise revolves around our server, our storage, and our networking solutions. Over the last 5 years, our high-volume servers have reduced our carbon emissions per unit of performance by 68%, while at the same time increasing performance per watt by over 300%. So the goal that we have and continue to have is around increasing compute and storage by orders of magnitude, while at the same time reducing the footprint and increasing the efficiency of our hardware and our hardware systems. There are two specific lines of servers that I want to talk about that are in the market today where we're achieving those. The first one is around our ProLiant G9 servers. These are servers specifically designed to match processing power with workloads in an effort to gain upwards to 20% energy efficiency. In addition to that, these G9 servers are also designed to operate at higher temperatures, as Dale stated, and at broader humidity environments, making it possible to require less cooling, less dehumidification equipment for data center managers. Right, so what we tout in our G9 series is the effective use of these systems brings about a 30% decrease in power, while at the same time boosting performance by up to 60%. So that's the first one, the G9 servers. The second one is our Moonshot platform, which is our data center in a package. And what that is, it's a system of cartridges that deliver low energy, efficient power consumption, very ultra-high densities at a flexible scale, right? So think about sharing management, sharing power, sharing cooling, sharing networking in these Moonshot cartridges in order to achieve upwards of 65% less energy, 90% less space within data centers, and also 98% less cabling than traditional servers. I'll give you a quick example of where we're using these technologies today. our energy efficient data center in Colorado Springs, we've outfitted with the G9 servers, and we've outfitted with the Moonshot cartridges. In addition to them, we've installed our flexible smart power supplies to further reduce power consumption, and we virtualized the storage. So we're using our Store virtual software to achieve upwards to 60% space reductions on these systems. And you can see some of the numbers here: drastic reduction in power use, drastic reduction in space at high efficiencies. Okay, so in the last couple of minutes that I have, I wanted to focus on the future at HP, and one of the most exciting things, and really the biggest research project that we're working on, which is the machine. So think about a system where every computation, every communication, every memory action is designed to consume the least amount of power possible, and that's the machine. All right, so we are taking efficient processing, moving entirely from general processing to workload task-specific system-on-a-chip processing, making it possible for significant compute and performance efficiencies. We're also using photonics, our photonics research, which is basically doing away with copper and moving to light. So, for example, communicating within the machine using light as opposed to electrons. And then the last thing we're doing is introducing universal memory, or collapsing the memory and the storage together. So millions of lines of code and executable programs remain static, remain on the systems. Finally, one of the future developments of the machine is all around our memristor technology, which is making that universal memory non-volatile. So no longer will you have to use enormous amounts of power to run your memory. No longer do you lose data anytime there's a power outage, and you can have incredibly high densities in this non-volatile memory. And the key part of that is it uses 1/1,000,000th less energy than the typical memory platforms today. So we're very excited about this. We think this will be the future of data center sustainability. And I want to leave you with the thought that efficient IT really drives data center sustainability. Along with the operations, along with the regulations, using efficient use of IT brings power, cooling, space, and resource savings to data center and data center managers. Thank you.
Thank you very much, Orlando. And now we'd like to introduce the President and CEO of Siemens Government Technologies, Barbara Humpton.
Thank you very much. We're sitting here talking about data centers, and you'll see on the title of my chart here, it says, beyond the IT, there's the OT, the operational technology. And this is a really complementary topic to what Orlando just talked about. You see, at Siemens, what we care passionately about is getting power generated and transmitted and transformed and distributed to the places where it's needed. And most of us, when we think about data centers, think about the servers and the applications that are running inside that data center and don't give a lot of thought to what powers that data center. So while HP is busy making their IT equipment incredibly efficient, Siemens is busy looking at how to solve the problem of not losing power as it's delivered to that data center, and then takes care of things like the facility management, the actual automation of the building itself, the physical security of the space, the fire safety of the space, and doing all that in a way that enables a small, I'll say, elite team to be able to efficiently manage that facility. Now, think about this. Who depends on uptime in data centers today? I will tell you, almost all of us do. Billions of people around the world depend on being able to get their data. And so what happens here with that operational technology is incredibly important. And a topic I'm going to come back to, and I hope we'll talk about a little bit, is how incredibly difficult that is to do in a federal data center, where the stakeholders who drive that data center can be very different people with very different objectives. The person who needs the IT might be the CIO. The person who's running the facility itself may be running multiple facilities and care about the heating bill. The person who's paying for the communications buses that bring the data in and out may be somebody entirely different. Getting those stakeholders aligned so that we can drive efficiency in a data center is extremely difficult. Now, there's an opportunity here to actually drive more efficient data centers and use something called an energy savings performance contract. Extremely challenging to do with that many budgets and people involved, but something I'd like to take on into further discussion with those of you who have a real interest in it. What I'd like to do in these remaining couple of minutes, though, is show you just an example. If you're thinking about your information technology and not thinking about your operational technology, just take a look at what can be accomplished in the area of cooling. You've heard about more efficient platforms. Still, you also heard from Orlando, there are unused assets, et cetera, within a data center. It can really wreak havoc on a cooling system. We're taking looks at how to better manage that environment and put more controls in the hands of the facilities managers so they can independently guide and govern. We've seen examples of reductions in energy use from as little as 15% to as much as 50% in facilities due to upgrading this technology. And when you look at that, it's not just a matter of are we controlling temperatures more efficiently. What you quickly discover is that the kind of controls that give you this kind of access and insight also enable you to find the things like the ghost servers that need to be removed or managed. They help you do more real-time monitoring. They help you plan for maintenance within the facility. So what we see is a multifaceted benefit as facilities managers and sustainability managers attend to that operational technology in the data center. Now, I'll just leave you with this, because uptime, reliability, efficiency, these are our objectives in the data center. As I say, it's a multi-stakeholder environment in the government sector. And it's something that we really are going to have to work on alignment for in order to have all those multiple stakeholders understand how they can drive greater efficiency. Thank you.
Thank you very much, Barbara. And now to moderate our data center discussion, GW's Director of Research Technology Services, Don DuRousseau.
Thank you. Good afternoon. Well, those were interesting presentations, and it appears with Dale's conversation around kind of platforms and ways of understanding their utilization, and yours with respect to systems and types of servers and storage systems, and yours with respect to kind of the operational integration and oversight. I kind of have a question that I've put together for each of you, and then hopefully from the audience we'll also be able to have a question or two that we can ask. So Dale, given the complexity of the issues impacting the design and use of sustainable data centers, what do you see as the biggest challenge for government managers in reporting to their superiors?
Well, I think the biggest challenge in actually all sectors is where the majority of servers are, and that's in very small data centers or server rooms or closets. And you know, if you're in a megawatt plus or double-digit megawatt data center, you have enough sort of cash flow to buy the engineering and put it out to bid. But we have a lot of data centers riddled throughout all the buildings. A lot of times the operators or the owners really don't even know where they are, and this is a big problem that's difficult to challenge. There's, you know, one option is to consolidate and move those data centers. We have server huggers, though, that feel the data that their server needs to be near them. So there's institutional barriers to go over. And then the other difficulty is where you really do have a requirement for a local data center. For example, in a hospital where the data has to stay on site. So these data centers are going to be the challenge, and I'd say is one of the biggest challenges in meeting our goals. And even how do you meter those? I mean, we're required to report PUE and meter them, but how do you meter a closet?
Exactly. Well, thank you. Orlando, from a kind of a hardware systems perspective, what advice would you give executives today that lead sustainability programs to help them understand and report the key performance indicators that they need to be aware of?
Yeah, good question. And I was sitting in one of the previous forums around agriculture sustainability, and there was a similar answer as what I would give. And it's really to make sure you have a plan and understand what you're trying to do and to not boil the ocean, right? To start small. So for example, if you are planning a data center sustainability project, the first thing you should probably do is understand what your carbon footprint is. And there are a number of government agencies and a number of companies, two of them here, that can help you to do that. But once you have your carbon footprint, you're able to determine, are you above, below, or where you should be in terms of your environment. And then in addition to that, you really need to decide from a key performance indicators or a KPI what you want to work on first. For example, do you want to reduce your floor space, right, and make that a KPI? Percentage of floor reduction. Do you want to decrease power usage? Percentage of power reductions. And then you take that as the start of a sustainability program, and you can not only monitor it, but you can drive towards a plan that will achieve your results.
Great. Barbara, in your opening remarks, you mentioned the challenge caused by the many stakeholders in the data center that have fingers in different aspects of that pie. Do you have any advice for the audience about how to navigate that complexity?
Well, I do, and I'll tell you, we're working with several partners in government who are dealing with this kind of problem today. And I would say if you're in that boat, if you have a sustainability responsibility for your organization, I would pay a lot of attention to the data centers. And the first thing I'd look at is what's the contractual sort of structure around the data center. You know, when is there an opportunity to renegotiate things like the facility use, the electricity coming in, the communications connections, et cetera, and get the owners of those functions aligned around future goals. And what I'd say is map out a plan that over time, with each contractual change, or with each change of responsibility, even within your agency, you build in steps toward your overall objective. Mm-hmm. I mean, a simple thing is, hey, I'm going to go renegotiate to get new technology in on the IT side. Why not try to structure the contract in a way that you get the contractor engaged in investments in the kind of efficiency you're looking for? Those kinds of things are out there as opportunities. I'd be willing to engage in discussion and help as a partner as you all work through your efforts as well.
Great, thank you. If there are some questions, we can take those. I'll think of, I think there's one other that I can ask each of you from the perspective of data center sustainability today. Thank you. What do you see as the low-hanging fruit? Dale, and I'll start with you, as far as something that's most easily adapted today.
Yeah, I think the easiest thing is control tuning and optimizing the controls. I mean, invariably, we'll go into a data center that's served by multiple crack units. That's computer room air conditioners. And the set points are set cold. The set points are set very tight. Back in the 50s and 60s, we had to have tight humidity control because we had paper in our data centers. I mean, there's a few gray-haired people here that remember cards in data centers. Humidity control was critical in those environments. Today, the humidity for HP servers is 10 to 90%. I mean, in essence, you don't need humidity control, yet our crack units are set for 55 plus or minus 5. So what happens is the crack units are fighting one another. So if we can spread the set points apart, you usually can see 10, 20, 30% savings of the crack energy use. But that's one example. Every data center's got different opportunities, but that's one that we commonly see. Great.
Orlando, yourself, same question.
Yeah, I think it's really driving efficiencies, and then I'll piggyback on that onto the IT side of the house. We talked a little bit about the amount of servers that are sitting there idle, not doing anything. Just turning them off, just blocking the plate there, and not having to cool those servers is an incredible uptick on that. In addition to that, just using best practices, right? Again, from a cooling perspective, do you need that much cooling? The average data center today cools at probably 2.6 times what it needs, right? Cranking that back is an incredible amount of savings there. So that's how I would address it.
Great, thank you. And Barbara, same question?
Well, similar. I'll put a twist on this. A lot of people are using excess heat produced by a data center as cash in the attic, right? They're saying, hey, I can take the excess heat from a big, power hog like a data center and use it to drive power production. We had a facility inside Siemens that was completely monitored, measured, and taking the waste heat from a data center to actually sustain the rest of the office building. So there are opportunities there to make good use of the assets you have.
Great. Well, there was 3 great examples. I do have a question from the audience. As we know, data centers generate tremendous heat. Have you explored opportunities to use that waste heat? There you go. Somebody's right on track there. One example is in Seattle, where an Amazon data center is providing heat for a local district energy project. So
yeah, all right. So this is huge right now. And in fact, there are federal goals for combined heat and power, right? So the opportunity to take heat, produce steam, drive a turbine, generate electricity, there are many, many ways to harness and use that power. It's a great concept.
Great.
So as we go to more sophisticated cooling systems like liquid cooling, to the chip, the temperature of the effluent gets a lot more useful. I mean, the chips require like 180 degrees F, so if we cool at 140, say, as an example, I mean, that's much more useful than, say, 70-degree air. But in any event, I mean, in our new supercomputer center, we're using the waste heat to heat the offices, so we don't plan to use any fossil fuels for space heating. And then in another data center, we use rear door heat exchangers that draw the heat as the air leaves the servers, and that goes into a water-fed heat pump where the temperature is elevated to a more useful temperature, and we use it in a neighboring laboratory that requires reheat for precise temperature control. So it's an application where we need heat year-round, and we're taking it from the data center and using a refrigerant process, a heat pump, we're elevating it to a useful temperature.
Excellent. We have 1 more minute, so I thought I would just ask if there's any takeaway that you could each offer to the audience today, and I'll start with you, Barbara.
Oh, this is important. There's nothing more important than attending to the efficiency of data centers, because typically they're using almost twice as much power as typical office space.
Mm-hmm. And I would add that this is also very hard, right? So you take it one step at a time. You develop a plan for sustainability that is achievable and where there are metrics that you can achieve at each and every step.
Yeah, and to measure those metrics, we need that instrumentation in place, and hopefully we'll get there or get close to it by the 2018 goal.
Excellent. Well, thank you very much. I appreciate everyone's inputs today.
Thank you.